Hello and welcome to Minnesota. We're going to look at a case study of an ice sheet and the landforms that they create. Ice sheets are huge. They are continental scale ice deposits. At the moment, the best examples are the Greenland ice sheet. But in the past, this was part of a much bigger ice sheet called the Laurentide ice sheet that covered Canada and parts of North America. And this was part of the last glacial maximum, up to 15,000 years ago. We're going to look at a couple of points for our case study. First of all, we're going to talk about the physical factors that influenced our ice sheet: the geology, climate, latitude, altitude and relief and aspect. We're going to focus on Minnesota, which is found in America. It's a state not far from Lake Superior. The geology. The geology is key, and a lot of it has been deposited or carved away by the ice sheets. Minnesota's oldest rocks lie in alternating belts of volcanic igneous rocks and sedimentary rocks in the northern part of the state, the grey, blue, pink and purple. But further south there is granitic rock. The climate. Of course, this was covered by an ice sheet, so it meant that there was a very vast, thick, cold climate, and that lasted for 2 million years. And it led to the development of 4 main lobes. These are tongues of ice that stick out. The rainy lobe, the Wadena lobe, and the superior lobe in the north particularly influenced the landforms we're going to look at. And they led to this really unique relief that we can see on this map here. Very mountainous areas that have been carved out, but areas that have also got very deep lakes. Some of those mountains were worn down by up to 700 meters by the ice sheet itself. The latitude and aspect are also important. Minnesota is located just on that boundary at the extent of the last glacial maximum. So it was experiencing erosion, but also deposition. And those lobes had a big part to play. Let's talk about some landforms. We want to know the interrelationship of a range of landforms within this landscape. Here we have a diagram, and it shows us some of the landforms that are created by ice sheets, particularly things like kettle lakes. But we're going to start with till and till sheets. Ice sheets are so huge they can deposit till over hundreds of miles, and those lobes we talked about did exactly that. They deposited large expanses of till covering most of Minnesota. They also helped to create not just drumlins but fields of drumlins. Drumlins, remember, are oval-shaped hills that are often formed through deposition, particularly during periods of rapid melting. The Wadena lobe was deposited in the drumlin fields of Otter Trail, Wadena and Todd counties by those glacial lobes. We also have moraine, and these are just not small terminal or recessional moraines, but large areas of ground moraine found in places like St. Cloud, Minnesota and St. Paul. Lakes. Those big lobes eroded some really deep depressions that have become lakes, proglacial lakes particularly. Those glacial lobes experience rapid erosion at a very fast rate because of their movement, which caused over-deepened hollows which filled with rain and became these proglacial lakes. We also have kettle lakes. These are formed by ablation in ice sheets. Isolated sections of ice create these kettle holes which fill with meltwater and rainwater. And then finally, our last point for this case study is how and why landscape systems change over time. They can change really quickly in short term because of weathering that causes rockfalls, but also in the long term they can modify the landscape by having subsequent ice ages move and reform those landscapes. So what do we need to know? We've got 3 key points here. Check them, make sure you've got information and detailed facts for this case study on each of those 3 key points.